We're going to look at algebraic expressions and models. First thing we have to do is cover some vocabulary, and our first one that we have is a numerical expression, and a numerical expression consists of numbers, operations, and grouping symbols. Grouping symbols would be parentheses or brackets. A variable is an item. It's usually a letter, but it can actually be a variety of different things, and it is used to represent one or more numbers. An algebraic expression is an expression involving a variable. So as long as there's a variable somewhere in it, it's an algebraic expression. And a mathematical model is an expression that represents a real-life situation. Okay, the next set of vocabulary, a term. Now this one's more important than any of the last four we just did. And a term are the different parts of an algebraic expression that are added or subtracted. So if I were to have an algebraic expression like 3 minus 2x squared plus 4 minus 8x, it says it's the parts of the expression that are added or subtracted. So the 3 is a term. That is a term. The 2x squared, or the negative 2x squared. The 4 is a term. The negative 8x is a term. So anything that's being added or subtracted is a term. So this expression right here would actually have 4 terms. Okay, a coefficient. When a term of an expression is the product of a number and a variable, the number is called a coefficient. So if we break this definition down, because that can be kind of confusing there, it says when a term of an expression. So we're talking about just a single term in one of these expressions. And it says when that term is the product, well, product means to multiply, of a number and a variable. Well, a number, maybe I want to pick the number 5, and for my variable, maybe I want to pick the variable w. So if this were a term in some algebraic expression, it says the number is called the coefficient. So our coefficient would be just a 5. If we look back up here, I first need to find the terms that have a variable and a number in there, so the negative 2x squared and the negative 8x. In the first case, my coefficient would be negative 2, because the sign in front goes with it. So my coefficient would be negative 2, and in this one, my coefficient would be negative 8. We will use coefficients, that term, a lot. Okay, and then the constant term is the term with no variable. So in the case up here, we have a 3, that would be considered a constant. We have a 4 would be a constant. Now it's not normal to have 2 constants in an expression because we would normally combine these. We would simplify them. So we would have normally added the 3 and the 4 and gotten a 7, so then 7 would be our constant. But a constant term has no variable. And if you think about that, when you have something with a variable, the value of this term changes. Like if w was equal to 1, the value of the whole term would be 5. If w was equal to 2, the value of the whole term would be 10. Well, a constant, think about what constant means. It means not changing, has no variable. So if I have a constant term, let's say of 7, no matter what w is, the 7's not going to change because it doesn't have a w in it. So that's why it's called a constant term. Alright, our last vocabulary word is equivalent, and that basically means equal. And our definition says that expressions are equivalent if they have the same value for all values of their variables. Now, what that might look like, it could be something as simple as like 3x plus 2x equals 5x. Expressions, so we're talking about more than one expression. So here's our first expression, 3x plus 2x. Here's our second expression, 5x. They are equivalent. They're equal to each other if they have the same value for all values of the variable. So it doesn't matter what value I put in for my x, I'm going to have equal values. Okay, the next thing we need to look at is the order of operations, and more than likely this is review, but it doesn't hurt to revisit it. And you can use the little saying, "Please excuse my dear Aunt Sally," to help you. And if you remember that, the P of please stands for parentheses. when we are evaluating expressions, we always use parentheses, or we always do the parentheses first. And now the parentheses don't have to be rounded ones. It actually can be any grouping symbol. It can be square brackets. It can be regular parentheses. It can be those types of parentheses. So when they say parentheses, it's actually any kind of grouping symbols. The E for excuse stands for doing the exponents. So once we get whatever is inside the parentheses done, then we focus on the exponents. The M and the D go together. If you think of these as different power levels, parentheses is by far the highest. It's the first, most powerful. Exponents is next. Now multiply and divide, even though in our little saying M comes before the D, these are equal. They are equal to each other. So multiply and divide, they're inverse operations, so they have the same power. Well, when you get into a situation where you have multiplication and division, you always go left to right. And then the same thing happens with our A from Aunt and our S from Sally. It's addition, subtraction. The last thing we're going to do when we are evaluating an expression is addition and subtraction. Now, if that's all you have left and there's more than one of them, you work from left to right. Okay, here's our first example. Go ahead and pause the video, and without a calculator, I want you to see what you get for number 1. Okay, when you do this one, I'm hoping that you realize the only operations we had was subtraction and addition. We didn't have parentheses, we didn't have exponents, we didn't have multiplication, division, we only had addition, subtraction. So I need to work from left to right. This is critical here. This is a very common mistake that my students make. You go left to right. So the first thing you do is 7 minus 3. Well, 7 minus 3 is 4. Then I go ahead and do the plus 2, and I get this to be equal to 6. Now, watch what happens if you do this without going left to right. If you chose to do addition first, you would have probably looked at this and said, well, 3 plus 2 is 5. And then I have 7 minus 5. Well, 7 minus 5 gives you 2. That is not correct. Because addition and subtraction are the same level, you have to go left to right. This is a common mistake that my kids make. Okay, now go ahead and pause the video again and give number 2 a shot. Make sure you follow the order of operations exactly. Alright, our order of operations says we do parentheses first. So I look inside of my parentheses, and I'm going to do 3 plus 2, which gives me a 5. Then it says do my exponents. So right now I have 6 plus 4 times 5 squared minus 4 plus 8. Well, I do have an exponent here. I have a squared. Now realize this squared is only attached to the 5. So I am only going to do the 5 squared, which is 25. So now I have 6 plus 4 times 25 minus 4 plus 8. There aren't any more exponents, so now I go into multiplication and division. Here I have a little multiplication problem. So I'm going to do that before I do any addition or subtraction. And 4 times 25 is 100. So I'm now left with 6 plus 100 minus 4 plus 8. And then from this point, now you can do your addition subtraction, but you have to go left to right. So start with 6 plus 100, and that would give you 106. Then do the 106 minus 4, that's going to give you 102. Add your 8, and you're going to end up with 110. So it's critical that you follow these order of operations precisely. Okay, now I want you to pause the video again and see what you come up with for these two problems here. For the first one, our variables. The only variables we have are y and x. Now, you don't have to write down x squared because this squared is not a variable. That's an exponent. So our only variables are y and x. Our constant term is the 2. Everything else has a variable attached to it. So our constant is the one without the variable. That's the 2. Our coefficients. I have a 6 because it's attached to the y. We have a 7 that's attached to the x. and we have a negative 9. The sign goes in front. So you might go back and, well, why didn't I do that with the 7? Well, the sign in front of the 7 is a plus, which means positive, so we don't actually have to say positive 7, because if you say 7, it's just assumed to be positive. And let's see, the number of terms. There are 4 terms. For the bottom one, evaluate the expression. We start with parentheses. Well, now this one, the parentheses has a lot of stuff going on inside of there. So we have to do our order of operations within our parentheses. So within my parentheses, there aren't any more parentheses. There aren't any exponents. So I'm going to go to multiply and divide. Well, right here I have a multiplication problem. So I took 4 times 2 and I got 8. Then from this level, I'm still inside my parentheses, and now I'm down to addition subtraction, so I have to go left to right. So I have to do this 6 minus 3 first. That gives me a 3. Then I'm still inside those parentheses. I can do the 3 plus 8 to give me that 11. Now I've gotten my parentheses down as far as they can go. I still have parentheses here, but there's nothing I can do inside of them. There's no addition, subtraction, multiplication. There's nothing. It's just a number. So now I can move on. Done with parentheses. Don't have exponents. Now I need to do multiply and divide. I have multiplication between my 4 and my 11, but I also have division here. Well, since they're of equal power, we go left to right. 4 times 11 is 44. And now I can do the divide by 2. Because division would be next. I only have division and addition here. And 44 divided by 2 is 22. Then I can do the add 6, and I end up getting a 28 for that one.